Hi, this video works through problem 6 from the review exercises. Problem 6 says at the beginning of each game that the New England Patriots play this season, there will be a coin toss. Let X be the number of coin tosses the Patriots win out of the first 3 games of the season. Let Y be the number of coin tosses that the Patriots win out of the first 5 games of the season. Let's assume we're looking at next season because this season they've already played 5 games. In any case, we're going to think first about whether X and Y are independent and use our intuition to explain why. So I would say, first of all, it seems pretty clear that these variables are not independent because, for instance, if I don't win the coin toss in any of the first 3 games, then I can at most win 2 coin tosses in the first 5 games. So there's clearly a relationship between these variables. So it seems clearly that they're dependent. And then part B asks, based on our intuition, would we expect the covariance to be 0, greater than 0, or less than 0? Now, if they were independent, I'd say, well, I expect it to be 0. And then when I'm thinking about would it be positive or negative, if I expect like when X is large, Y is also large, that would make it a positive type of covariance. If I thought that when X is larger, Y tends to be smaller, then that would indicate a negative. And so it only makes sense that the more coin tosses you win sort of in the first 3 games, the more you'd expect to have won after the first 5 games. So it should probably be positive, is what we'd be expecting. Okay. So part C asks to make a table showing the joint probability mass function of X and Y. And I've actually already done this here because you don't want to watch me stand here and draw this whole table. But let me just talk a little bit about how I found a couple of the values. When I'm thinking about sort of like 0 and 0, that would mean they don't win any in the first 3 games and they don't win any in the last 2 games, in the 4th and 5th games either, if you kind of think about it. So what that would mean is that if they have a 50% chance of winning each time, that they had to have lost all 5, right? So it would be 0.5 to the 5th power is going to give me my f of 0, 0. If I want to think about my f of 0, 1, well, what that would mean is that I would have lost the first 3 but won 1 of the last 2. So that could happen. I'd be like, okay, well, I've got 0.5 and I lose 4 times and I then win once, right? And there are 2 different ways that this can occur for me to win 4 out of 5. I could have lost the first 3 and then won the 4th and lost the 5th, or I can lose the first 4 and then win the 5th. But in any case, there are 2 of those that would result in this value, f of 0, 1. And so that's going to give me my probability here. So it's going to be 0.0625, and that's my f of 0, 1. And I can kind of reason through the entire table this way. So I'm going to post this so you can take a look at it if you had any trouble finding it. But this is sort of basically the idea of how we can find all these probabilities. We just have to kind of work through them. And this will be our joint probability mass function. Now, once we have the joint probability mass function, we want to find the probability mass function of X, the marginal one. So what I'm going to do that is I'm going to think about, okay, for each value of X, I'm going to add up the probabilities. So let's see, so that's part D down here. So X can take on the values 0, 1, 2, and 3. Probability it takes on the value 0. It's going to be the sum of these 3 probabilities. So 0.03125 plus 0.0625 plus 0.03125, and that is going to give me in total, let's see, 0.125. And the same idea, here I have 0.09375 plus 0.1875 plus 0.09375 gives me a total of 0.375. Probability that x is equal to 2 is the sum of these probabilities. So I've got 0.09375 plus 0.1875 plus 0.09375, which again adds to 0.375. And then the probability that x is equal to 3 is going to be 0.03125 plus 0.0625 plus 0.03125, just adding these three probabilities associated with x equals 3 gives us 0.125. And note that these sum to 1, which they always must. The marginal probability mass function of y this is part E. Y can take the values 0 to 5. So I guess I should say this is my so now I'm going to be adding across for all the different values of x to find the total probability that y takes on a particular value. So the probability that y is equal to 0 is just going to be 0.03125. The probability that y equals 1 is the sum, 0.0625 plus 0.09375, which gives us 0.15625. And continuing on, here I take the sum of 0.9375 plus 0.1875 plus 0.03125, which gives me 0.3125. The probability that y equals 3, I'm going to be summing 0.09375 plus 0.1875 plus 0.03125, which again is going to give me 0.3125. The probability that y equals 4 is 0.09375 plus 0.0625, which gives me 0.15625. And finally, the probability that y equals 5 is just this 0.03125. And again, these probabilities have to sum to 1, and they do. So there's my marginal of y, my marginal of x. The last part of this question asked me to find the covariance of x and y. If you recall, the covariance of x and y can be found by taking the expected value of x times y and subtracting off the mean of x times the mean of y. So I'm going to start by finding the mean of x and the mean of y. The mean of x is going to be 0 times the probability that x is equal to 0 plus 1 times the probability that x is equal to 1 plus 2 times the probability that x is equal to 2 plus 3 times the probability that x is equal to 3, which gives me the mean of x equal to 1.5. If I want to find the mean of y, it's going to be 0 times the probability that x is equal to, 0 times the probability that y is equal to 0, plus 1 times the probability that y is equal to 1, plus 2 times the probability that y is equal to 2, plus 3 times the probability that y is equal to 3, plus 4 times the probability that y is equal to 4 plus 5 times the probability that y is equal to 5. And if I go through and find that whole thing, my mean of y should come out to 2.5. Now I need the expected value of x times y. To find the expected value of x times y, it's going to be a bit of a tedious thing to do, but I'm essentially going to need to multiply x times y times their probabilities. Now, the good thing is, so I'm going to be summing over all of the xy pairs, x times y times f of xy. Right? Now, the good news is, when I take 0 times anything, I get 0, so I don't have to worry about adding these in because those products are all 0. When I multiply them by their probabilities, I still get 0. Same is true here, so it's really just sort of this piece that I have to worry about here. So this is going to be 1 times 1 is 1 times 0.09375 plus 1 times 2 is 2 times 0.1875 plus 1 times 3 is 3 times 0.09375 plus, moving on, 2 times 2, whoops, 2 times 2 is not 2, 2 times 2 is 4 times 0.09375 plus 2 times 3 is 6 times the probability of that combination is 0.1875 plus 2 times 4 is 8 times the probability associated with that pair, 0.09375 plus 3 times 3 is 9 times the probability of 3, which is 0.03125 plus 3 times 4 is 12 times the probability of 3, 4, 0.0625 plus 3 times 5 is 15 times the probability of 3, 5, 0.03125. Lots to put in your calculator, but the expected value of x times y should come out to 4.5. So then the covariance of x and y is the expected value of x times y, so that's 4.5, minus the mean of x, 1.5, times the mean of y, 2.5, and that gives us a covariance of 0.75, and that is our answer to F. So lots of calculations on this one, but there it is.